Hello my dear friends, now I am going to tell you from chapter number 5 how to check that whether the given series is converges or diverges. So this is exercise 5.3. This is exercise 5.3. We need to check that for integral test. Integral test means any power series which is given like that with a given infinite series. Suppose that an is equal to f of n, where f is continuous positive function, then the series this converges or diverges according to this rule. That means if we need to check any power series whether that one is converges or diverges, then integral test means this rule. This we need to use as a rule. This we need to as a rule. How we can implement? So I'm picking these examples from the exercise 5.3. Exercise 5.3. Exercise 5.3. Now I'm going to tell you that how to check question number A part. That means this one. So I'm going to tell you separately that one is A part is this question. So I'm going to check that A part. That one is summation from n is equal to 1 to infinite 5 divided by n plus 1. Need to check integral test. Use integral test for checking of whether this function infinite series is convergent or divergent. So for that, what we need to check, just in place of this we need to write fx 5 divided by change in place of n as x, then integral formula, that is from 1 to infinite f of x dx. Substitute the function fx 1 to infinity. Fx means 5 divided by x plus 1 dx. So when you simplify it, then it is 5 times ln of x plus 1, and use the limit. When you use the limit, it comes 5 ln of infinity plus 1 minus 5 ln of 2. Infinity plus 1 is undefined. That means this series is diverges. This series is diverges. Now I'm going to check B part. What is B answer of that question, that exercise? B is summation from n is equal to 1 to infinite 1 divided by 2n minus 1. So what we have to do? Just here, this is an. An is 1 divided by 2n minus 1. So what we have to do? In place of an, just write fx. Fx is equal to 1 divided by 2x minus 1. Then use integral test. Integral test is 1 to infinity fx dx and integrate it. That means 1 to infinity fx means 1 divided by 2x minus 1 dx. So when you integrate it, it will come 1 divided by 2 ln of 2x minus 1, and the limit is 1 to infinity. So again, when you use limit infinite, it will diverges. That means this question number B part is divergent. Question number B part is divergent. Now I'm going to tell you what is E part. That is E part. E part is summation from n is equal to 1 to infinite e power n divided by 1 plus e power 2n. So I need to check what is that. So in this question, it is given that an is equal to e power n divided by 1 plus e power 2n. It means that fx change in place of n x. So it is e power x divided by 1 plus e power 2x. Now by using integral test 1 to infinite fx dx. That means 1 to infinity, fx means e power x divided by 1 plus e power 2x integrated. So see that one, how can I integrate? So can I write this one as 1 to infinite e power x divided by 1 plus e power 2x means we can write it e power x whole square. So now check that one. If you put e power x as the u, this means that e power x dx is equal to du. So this integral now change as 1 to infinite e power x dx. E power x dx is du divided by 1 plus e power x means u square, because e power x is given here. See that one, e power x dx is du. So in place of this we can replace du and divided by 1 plus e power x means u, so it is u square. So what is the integration of that part? The integration of that part is tan inverse of u, and use the limit, or tan inverse of u means e power x. So it is 1 to infinity. So when you replace tan inverse of e power infinity minus tan inverse of e power 1. So see that one, tan inverse of e power infinity means infinity. So tan inverse infinity, that means it is coming tan inverse infinite minus tan inverse of e. Tan inverse infinity means pi by 2. That means it is converges. The power series is converges, because converges means when it gives us some result. When it is not given some result, that means diverges. Because of tan inverse infinity means pi by 2, so that means it is converges. Similarly, if you try to f part, just I am writing few questions, you can try by yourself. F part is divergence. Now I am going to check J part. What is J? J is given summation from n is equal to 1 to infinite 1 divided by n square plus 1. So what you have to do, see that one, in place of an it is given 1 divided by n square plus 1. So write it in fx form. So 1 divided by x square plus 1. So that integral test by integral test 1 to infinite fx dx means 1 to infinity, fx means 1 divided by x square plus 1. So integration of that one is tan inverse x, and the limit is 1 to infinity. So you know that tan inverse infinity minus tan inverse of 1. Tan inverse means pi by 2, and tan inverse of this one is some result, so it is converges. The series is converges. J part is converges. J part is converges. So hopefully you understand this one. Now I am going to tell you one question from the exercise which is based on that type of, that means find the interval of converges of the series 1 minus half x minus 2 plus 1 by 4 x minus 2 power 2 and so on. I need to check that one, interval of converges. So interval of converges is uh, for that type of series, we know that one there is series which is called as GP, AR, AR square, AR power 3, AR power 3, AR square, AR power 3, and so on. If this series is, then it is called GP. Then this series is called GP because of product is like that. Any series is written as 2, 4, 8, 16, 32, and so on. Then this series is called geometric progression because the term every time is coming from the division of that part. This divided by this. That means 8 divided by 2 is 2. 16 divided by 8 is 2. 32 divided by 2 is, so that means common ratio is same everywhere. So that's why. So converges, radius of convergence will be based on R. That means if R is this like that, then series is convergent. That means this will give you the radius of convergence. So what we have to do in place of this one, because of this is in GP, this is in GP. So R means this term. R is here minus 1 by 2 x minus 2. So what we have to do, solve it. Minus 1 by 2 x minus 2 modulus. So it is, this one is less than, that means 1 is greater than. So you know that one, this modulus term, this one is equal to 1 sometimes and minus 1 based on this. If x is plus, then it is plus. If x is minus, then it is minus. So this, if this one is greater than, so less than also. So we need to solve it for radius of convergence. This gives you radius of convergence. This term is give you radius of convergence. So solve it. So it means that 1 minus 1 is greater than half minus x minus 2 and minus half x minus 2 is less than 1. So when you solve it, so it will come, just multiply this, that one. So minus 2 less than minus x plus 2. So that means we need to solve the value of x. So when you try to solve, that means we need to write here minus 2 and here also minus 2. So minus and minus 2. So this will cancel. So it is coming minus 4 less than this one. Because of this is minus. So when you cancel this minus, it means x is, now it is x is greater than, now x is that, x is greater than 4. When you change, sorry, this is x is greater than 4. So now its symbol is changed. That means this is like that one. And when you solve this one, it is minus x plus 2 is greater than 2. That means minus x plus 2 minus 2 and add here minus 2. So this coming as this one. So x is greater than 0. So the solution of that one is x is less than 4 and greater than 0. This is the radius of convergence. That means this is the answer of that question. Hopefully you people understand that one.